Hello grade 10s, hope you guys are good. In today's video, we're going to be doing exam type questions for trigonometry. So without wasting any time, let's get straight into it. In the diagram below, A, B, C, A, B, C, A, C, D, and A, D, E are right triangles. And BAE is 90 degrees, BAC is 30 degrees, and then BC is 20, AD is 60 units, right? Okay, so before answering the questions below, let's see if we can figure out some of these missing sides and angles. So for triangle ABC, side BC is opposite to angle BAC. So it means you can use this opposite to also calculate AC using a sine, or AB using tan. So if you've gotten AC and then you also have AD, you can use Pythagoras theorem to determine CD. If you've got the angles for BAC and CAD, you can also minus them with 90 to get angle DAE, right? If you've got this angle over here, you can use 10 to determine this side over here, DE, or use cos to determine AE. So it should be relatively easier for us to answer the questions below. Let's start with 4.1. 4.1, they say we must calculate the length of AC. If you look at triangle ABC, we have the side that's opposite to the angle that's given to us, and we are looking for the hypotenuse. So it means in this instance, we are going to use sine to look for our side. 4.1.1 is going to be sine of 30 is equal to, what's our opposite? Our opposite is 20 over our hypotenuse, which is AC. Now, make AC the subject of the equation. If we are to make AC the subject of the equation, it means we have to multiply both sides by AC. That's going to give us AC multiplied by sine 30 equals 20. And then if we want AC to remain on one side, it means we have to divide both sides by sine 30. So you're going to say AC is equal to 20 divided by sine 30. And then your final answer is 40 units. In 4.2, they're saying calculate angle CAD. CAD. Now we already have side AC, which we said is 40 units. It means we have the side that's adjacent to CAD, and we also have the hypotenuse. So in order to figure out the size of angle CAD, it means we have to use cos. Cos CAD, which is equal to adjacent over hypotenuse. Our adjacent is AC, and AC is 40 units over our hypotenuse, which is 60 units. So in order to get angle CAD, you're gonna have to say cos -1, 4 over 6, or 2 over 3. And then what's your final answer? It's equal to 48.19 degrees. Right? Now we have this angle over here, and then we also have angle CAD. Now we can calculate angle DAE. Okay, here they say calculate the length of DE. And as you can see right here, it is for 3 marks. So it means that we have to do an extra step. So how are we going to get length of DE? First of all, you have to say angle DAE is equal to angle BAE, which is 90 degrees, minus angle BAC and CAD. So DAE is equal to 90 degrees minus 30 degrees minus 48.19 degrees. So what's DAE? 11.81. This is for question 4.1.3. For part 2, then you say, okay, we have the adjacent side to the angle that's been given to us, and then we are looking for the opposite side. So according to the trig ratios, what ratio should we use? 10. So you're going to write 10, 11.81 is equal to opposite over adjacent. So DE over adjacent, which is 60. So to make DE the subject of our equation, you multiply both sides by 60. And then you're going to be left with DE is equal to 60 multiplied by 10, 11.81. And then your final answer is going to be 12 units, 12.55 units. Now, they say we must solve for x, correct to 1 decimal place, where x is between 0 and 90 degrees. Okay, so this one is also very simple. You're going to say 10x is equal to 2.01. Then x is equal to 10 minus 1, and then type into your calculator. Your answer is going to be 63.5 degrees because it's correct to 1 decimal place. 4.2.2, it says 5 cos x plus 2 equals 4. Right, so first things first, you're going to say 5 cos x equals 4. Take 2 to the other side, minus 2. You're going to be left with 5 cos x is equal to 2. Divide both sides by 5. You're going to be left with cos x equals 2 over 5. And then to get to your final answer, you say x is equal to cos, and then open bracket, 2 over 5. If you type that into your calculator, what is your answer? 66.4, correct to 1 decimal place. For our final question, 4.2.3, it says cos x equal over 2 equals to 3. So to make cos x the subject of the equation, multiply both sides by 2. You're going to be left with cos x equals 6. Now, we all know that cos x is the inverse of sine. So you're going to say 1 over sine x is equal to 6. To make sine the subject of the equation, one thing you can do is you can apply inversions on both sides. So if you apply everything on each side to the power of -1, you're going to be left with sine x is equal to 1 over 6. And then make x the subject of the equation. And then your final answer is going to be 9.6 degrees. So yeah, we're going to do more examples in the next session. For now though, peace.